Most people think of trees as silent, peaceful giants. But what if they could actually warn us about erupting volcanoes? Thanks to NASA and the Smithsonian, scientists have discovered that trees near volcanoes absorb rising carbon dioxide from magma, making them greener before an eruption. And now, satellites in space are tracking that greening to detect volcanic unrest before disaster strikes. In this episode, we dive into how forests might just be nature's early warning system.
To the deep dive. Okay, so imagine this. What if nature itself, specifically trees, could give us a kind of early warning about volcanic eruptions?
It sounds a bit like science fiction, doesn't it? But that's exactly what we're digging into today.
Yeah, exactly. We're exploring some really fascinating new research, and this comes with support from NASA and the Smithsonian. It looks at how trees might become, well, sentinels for volcanoes.
It's this amazing meeting point of different sciences.
Yeah.
The basic idea is that trees actually react to gases coming up from magma deep underground.
And scientists are figuring out how to spot that reaction, even from way up in space.
That's the goal.
So our mission today in this deep dive is really to unpack all of that. We'll look at why monitoring volcanoes is so tough, how trees are involved, how technology like satellites fits in.
And crucially, what this could actually mean for keeping people safe. Because that's the bottom line, isn't it? Safety in these volcanic zones around the world.
Absolutely. And this isn't just some obscure science topic.
No, not at all. It touches on, big things like earth science, managing disasters, the power of remote sensing. It's valuable stuff for anyone interested in our planet.
And potentially quite relevant, maybe, if you're prepping for something like the UPSC Civil Services exams, where current affairs in science and environment are key.
Definitely. That intersection of earth science, technology, and disaster readiness is a hot topic.
Right. So let's start with the basics. Volcanoes are dangerous, and knowing they're about to erupt is critical.
Hugely critical. I mean, think about it. Roughly 10% of everyone on Earth lives somewhere vulnerable to volcanic hazards.
And it's not just lava flows, right?
Oh, no. It's flying rocks, ash clouds that can choke engines and lungs, poisonous gases, devastating mudslides, even tsunamis sometimes. The impact can be just immense.
And you can't stop an eruption, so the only thing you can do is get people out of the way beforehand.
Exactly. Knowing it's coming is everything. And scientists, they already do a lot of monitoring, of course.
Yeah, they track earthquakes from the moving magma, right? And the ground swelling up.
Precisely. Seismic waves, ground deformation, gas emissions where they can measure them directly. But the real push is always for earlier warnings. Signs that show up before the big shakes or the ground bulging noticeably.
Which brings us to tracking gases. Because magma releases gases like CO2 and SO2 before things get really dramatic, doesn't it?
That's right. Sulfur dioxide, SO2, that's often a bit easier to spot from a distance. But CO2, carbon dioxide, that's the tricky one, especially those early smaller amounts.
Why is CO2 so much harder to detect early on? Is it just because there's already so much CO2 in the air normally?
That's exactly it. Robert Bogue from the Smithsonian, he put it really well. Volcanoes do give off CO2, but the atmosphere is just saturated with it already. So picking out that small extra bit from a volcano, especially the subtle increase that might signal an impending eruption, well, as Bogue said, a volcano emitting the modest amounts of carbon dioxide that might presage an eruption isn't going to show up in satellite imagery.
So trying to see that faint volcanic CO2 signal directly from orbit is basically impossible with current tech?
Pretty much. Which often leaves only one option: sending teams on the ground.
Which sounds dangerous and expensive.
It can be both, yeah. Especially for remote volcanoes. And, there's something like 3,350 potentially active volcanoes globally. You just can't monitor them all that way.
Okay, so this is where the trees come in. The clever idea. If you can't easily measure the CO2 itself, measure something that reacts to it.
That's the breakthrough concept here. Using trees as a proxy.
A proxy.
Yeah, like an indicator.
Yeah.
Instead of trying to see the invisible CO2, look for its effect on the surrounding forest. Bogue again. The whole idea is to find something that we could measure instead of carbon dioxide directly, to give us a proxy to detect changes in volcano emissions.
And it makes sense biologically, right?
Right.
Extra CO2 coming up through the soil. Trees near the volcano absorb it. It's like a sudden nutrient boost.
Exactly. And their leaves might respond by getting, say, greener or more vigorous. A subtle change, but potentially detectable.
Okay, a subtle change in the leaves. How on earth do you see that from space?
Well, that's where the satellites come back in, using remote sensing.
Okay.
Satellites like NASA's Landsat 8 or the European Space Agency's Sentinel-2, even NASA's older Terra satellite. They have instruments that can analyze the light reflecting off vegetation across different wavelengths.
So they're not just taking a picture, they're analyzing the color of the light.
Precisely. They can pick up subtle shifts in chlorophyll content, plant health, those very indicators that might signal that extra CO2 uptake.
Wow. And it's not just satellites. You mentioned airborne tools, too.
Right. Sometimes they fly instruments on planes for more detailed views, like the AV-WILO mission, that's Airborne Validation Unified Experiment, Land to Ocean.
Catchy name.
Yeah. NASA and the Smithsonian were involved. In March 2025, they flew a spectrometer over Panama and Costa Rica, basically getting super detailed plant color data from the air.
And Nicole Ginn, you mentioned her study on Mount Etna.
Yes, her work was really foundational. It was the first to really show a strong link between those tree color changes observed from space and actual CO2 coming from the magma below Etna. She noted there are plenty of satellites capable of this analysis.
But you can't just rely on satellite images alone, can you? I mean, a forest could look greener because of good rainfall, not volcanic gas.
Absolutely. Crucial point. You need ground truth. You have to go there on the ground and confirm what the satellites think they're seeing.
So boots on the ground, collecting samples.
Exactly. Josh Fisher's team did just that during the AV-WILO mission. They were down near the Rincon de la Vieja volcano in Costa Rica, literally collecting leaves and measuring CO2 levels in the soil right there under the flight path.
It really shows how different fields have to work together here. It's not just geology anymore.
Not at all. Fisher called it a two-way interdisciplinary intersection between ecology and volcanology, which is a great way to put it.
Ecology and volcanology working hand in hand.
Yeah. And he also mentioned, his work touches on this bigger question, too. How much CO2 can trees globally actually absorb? Which is hugely relevant with climate change.
Okay, so let's recap the potential here. We've got trees acting as CO2 sensors, satellites potentially reading those signals from space, and ground crews confirming it. What are the big advantages if this works consistently?
Well, the biggest potential advantage is earlier insight. Spotting changes possibly before other methods kick in.
Okay.
And it could dramatically increase the number of volcanoes we can keep an eye on, especially those remote, hard-to-reach ones. Imagine having a way to monitor hundreds more volcanoes from orbit.
That would be huge for early warnings.
Potentially, yes.
Yeah.
It could give communities more time to prepare or evacuate.
But as always, there have to be limitations, right? It can't be perfect everywhere.
Definitely not. Florian Schwanner, another researcher in this area, was clear. There's not one signal from volcanoes that's a silver bullet.
No silver bullet. So what are the catches?
Well, first, you need trees. Not all volcanic areas are forested. Different types of forests, different tree species, they might react differently or not noticeably at all.
Ah, okay. Makes sense.
And then there's other stuff that affects trees. Wildfires, droughts, floods, insect infestations, diseases. All these things can change how a forest looks from space.
So you have to filter out all that other environmental noise to find the volcanic signal.
Exactly. It requires really careful analysis, and that ground validation becomes even more important to make sure you're not seeing a false positive.
Right. But despite those challenges, the principle of using gas monitoring for early warning, that's already proven itself, hasn't it? You mentioned Schwanner had a real-world example.
Yes, a very powerful one.
Yeah.
Mayon Volcano in the Philippines.
Okay.
Schwanner was involved in upgrading its monitoring network. They added new sensors specifically for CO2 and SO2. And in December 2017, these new sensors picked up subtle but clear increases in gas emissions, signs of unrest.
So the system flagged something early? What happened?
Based largely on that gas data, government scientists felt confident enough to strongly recommend mass evacuations.
Wow.
And they did it. Over 56,000 people were moved out of the danger zone before a major eruption hit on January 23, 2018.
And the result?
The result was incredible.
Right.
There were no casualties, zero.
That's the goal right there. That shows the life-saving potential of good early detection.
Absolutely. And while this tree method is different, it's aiming for the same thing, tapping into those early, subtle gas signals that precede the main event.
So Schwanner's point was this tree technique might not be that silver bullet.
But he believes it will be something that could change the game. It could become a really valuable extra tool in the monitoring toolkit for many volcanoes.
So wrapping up this deep dive then, it's a pretty mind-bending idea, really. Trees, our everyday leafy neighbors, potentially acting as these quiet alarms for volcanic activity. and using cutting-edge satellite tech to listen in on what they're telling us. It's adding another layer to how we watch volcanoes, alongside the seismometers and ground measurements. And the ultimate aim is just better prediction, better preparedness, saving lives near active volcanoes.
Exactly. It's a fantastic example of innovation using satellites, mixing ecology with volcanology, all for practical human benefit. It's the kind of work NASA supports that pushes these boundaries.
It really is fascinating stuff. So if you listening found this interesting and you want more deep dives like this, please do like this session and subscribe to the channel. It really helps us out.
And if you have questions or just want to discuss this more, definitely leave a comment below. We do read them and enjoy the discussion.
Absolutely. Remember, this insight comes from that cutting-edge research supported by NASA and others who are constantly finding new ways to understand our planet.
Yeah, it's ongoing, exciting work.
Okay, so here's a final thought to leave you with, building on what Fisher said. We've talked about how sensitive trees might be to volcanic CO2. But think about the massive increase in CO2 in the entire atmosphere from human activities. If trees near volcanoes react subtly, what are all the plants everywhere subtly reacting to right now because of that background CO2 rise? And what might those quiet, widespread changes be telling us about where our global environment is heading?
That's a big question. Something definitely worth pondering.
Indeed. Until our next deep dive,